Welcome to Project 5, and today this is just a continuation of auxiliary views. So far we've done the folding plane method, we've done the plane method, auxiliary plane method, and now we're going to get into what's called the revolution method. Now, this revolution you can read through in your book, and you'll see some more of this in your text. However, I want to show you how this revolution works to be able to build an auxiliary. Now you have this document right here, this image, and it's on Blackboard. You can open it up and take a look, and it's real easy. The revolution method is. If you look here, this is the auxiliary view method. Now this would be your front, and they're using this one as their top, and this is how we've been doing it in the past. This is the fold line method. And you can see that they come up here, they use this as their primary auxiliary line, and then they fold it down and get the true size. Of course, looking at it from the top view, and it says right here, this is not true size, it's foreshortened. Up here, this is the edge view, and whenever we fold out, we get the true size of that plane. Well, if you want to use a revolution method, look over here on this example. What you do is you take, just like this one would be the top view, you get to this point right here and revolve it to where this primary auxiliary line is perfectly horizontal. It depends on what you're working with. And once you do that, you have new projection lines that shoot down. And when you do that, if this one's perfectly straight, the edge view is perfectly straight, it folds up, and you will have automatically true size when you draw this. So I want to show you an example of this. On the left hand side here, you got your top, front, and right side, and it's showing this object. It's foreshortened there on the right side view. And so this right here is a primary auxiliary. This is our true edge, is a true length of our edge view. And then I projected it up here. I just done a plane method to do this one. And I come up and of course project straight off that. These lines have to be parallel with this, and of course there it is. It just projects up. You got your true surface, true shape of that, and these are foreshortened here. This part's foreshortened, and this part is this area is foreshortened. I want to show you another method over here. It's our revolution we talked about. I want to zoom that in, and how to do this is I know this is my primary auxiliary, so I want to revolve this to where this one's perfectly horizontal, and I'll show you how I would go about doing that. So I'll close that out for the time being. This is how I would go about doing this. I come up here and I hit mirror. I grab this primary auxiliary line, and then I snap right there with my ortho on, come straight across, and you can turn it on, but it was running straight anyways. Make sure that's running straight, and it puts a line up here just like that. It's perfectly mirroring that primary auxiliary line. Take and rotate everything besides that line that I just put there. Right click, and the base point would be right there. So now I'm going to start to rotate that thing up, and I want to catch that end point of that. So these things are revolved according to this angle here that we just put in. Our top and right side, you see how it turned on us? Now, to draw this auxiliary view, why, it's going to be rather simple, to be honest with you. There's no exact space where you have to put it at. I'm just going to hit offset, and this is a rather small piece, like let's do 1.5 inch offset. Grab that, offset it up, and like I always told you, I like to extend that line a little bit longer. Hit extend, grab that line, this line, right click to enter it. We'll shoot that line out there just like that. And again, we just need to find the depth of this object, and to do that we'll just use an alignment. .7.422, an odd number. I just hit my offset, 0.7422, enter that. grab that line and just offset it up. So there's our depth for that. And you can probably already see it. Just come in here, grab your lines, come up here, and I could turn my perpendicular on in my object snaps if I want to, instead of having to control right click to get them. Probably a lot faster in the long run. Come up here and grab that. Perfect. That perfect. That perfect. And that perfect. And now the thing you have to do is just trim it out. And there she is. Now at this point I'm going to delete that out. You've got that set up, and you can actually just revolve it back. And to revolve it back, I do the same thing I did earlier. I just use a mirror. I grab, and see that's a complete polyline at that point. I'll just grab that and explode it. Do my mirror on this. Make sure my line's going across straight. And grab everything but that mirrored line that I just made. Rotate, grab that point, and come down here and catch the end point of it. Wow, that's as good as it gets. And now, if we come in here and do a copy, I'm just going to copy and bring that true size over into this box. So this is the same auxiliary, same way I did the plain auxiliary method over here. This works the same way. It just you're taking and making this run this flat, and it depends on where the angle's at, how you're going to do it. But that's basically how you revolve it and get that shape. And to check it, let's go up here and let's just do an area just to make sure that this is all right. And I got area 0.458. 0.458. And this one's 0.458, same thing. So either way that you do it, any of the three methods of designing auxiliaries, it all comes out the same way. They're all good methods. It's just up to you which one you choose to use. But for this project and Project 5, you're going to use the revolve method to be able to add an auxiliary view to the two drawings that's on Blackboard.